Hello students, welcome to online Vidyarthi math sessions. So in this lecture, let's continue the discussion on the chapter called statistics. Statistics is a chapter branch of mathematics which is studying about the data and the characteristics of the data. So to learn the characteristics, to study the characteristics of the data, the first and foremost thing that we need to study is central tendencies. So in the previous lecture we had discussed about central tendencies. So there are three types of central tendencies that you observe. Those are mean, median and mode. The mean has again three types. Those are AM, GM and HM. Arithmetic mean, geometric mean and harmonic mean. When it comes to median, as we know, median is the observation which lies exactly in middle for the arranged data, either in ascending order or in descending order. So as it is median dividing into two halves, we call that one as median. So the several types of medians are there. Instead of taking into two halves, we can make into 4 equal parts or 10 equal parts or 100 equal parts. So if the data is made into 4 equal parts, those are said to be quartiles. So here quartiles, and the another type of median that you can calculate is deciles, which divides into 10 parts, and percentiles. So here the most important thing that you should remember is quartiles, because based on the quartiles we can study the dispersion of the data or the spreadness of the data or scatter in the data. So this is one of the parameters that you can learn there. So this one is nothing but here when the data is made into 4 equal parts, the first equal part, the first one is called Q1. This is called lower quartile, and the third one is Q3, that is called upper quartile. So for the median you had a formula, right? For if it is discrete or individual series of data, if you got, then n plus 1 by 2 you got that one as a median. So here lower quartile for the individual series, it could be n plus 1 by 4th observation is the lower quartile, you can consider. N plus 1 by 4 into 3 is considered as this term, or else 3 by 4 terms of this one is called upper quartile. So when it comes to the continuous frequency distribution, then the lower quartile and the upper quartile will be given like this. You have the formula, this one. So L plus n by 2 minus C by F into H. This is the formula for the median for the continuous frequency distribution that you have seen. So this is median for the continuous frequency distribution. If you need to convert that into the quartiles, the lower quartile Q1 can be considered as, instead of 2, if you put here 4, you will get the lower quartile. If you substitute Q3, then if you want Q3, that is upper quartile, then L plus n by 4 is multiplied by 3 times, that is 3n by 4 minus C by F into H. This is called the upper quartile for the continuous frequency distribution. So these are the upper quartiles and lower quartiles. This will be useful while finding the spreadness or the scatter or the dispersion of the data. So that is while studying the interquartile range. So you know up to the range in the previous standards. So interquartile range that you should know, that is one of the measure of the dispersion, but you doesn't require to concentrate on that much, just to know what it is. Clear? Because in the syllabus or else in the exam we are not going to get the questions much on this. Clear? So just remember this. The medians can be calculated in other ways, that is into the quartiles, in deciles and in percentages. Quartile means made into 4 equal parts. Which one? Data. If data made into whatever the data that you have, made into 4 equal parts, this is quartile, made into 10 equal parts, this is decile, and made into 100 equal parts, this is percentile. So just to remember this one. And mode, you know that the observation which repeated many number of times, that is called mode. Clear? Now let's enter into the measure of dispersions. Clear? Alright students, so let's see the measure of dispersion. Let's learn the concept about measure of dispersion. So what is the meaning of dispersion, that we'll see now. So this dispersion is nothing but the data what you have is that whether closely packed or is this or loosely packed. That is nothing but if the data is have more dispersion or less dispersion. If more dispersion is there, then that is less consistent. If the less dispersion is there, that can be considered as more consistent. So it's about homogeneous data or not, to find out that you will see now. So the homogeneous data means that is more concentrated, more consistent, that is less dispersed. So this all it is useful while finding the business mathematics to take the decisions about the data what you have from the previous incidents. So by using that data, if you need to take any decisions for the future at that time, it will be useful a lot. So that we will see now how to find the measure of dispersions. So to find the dispersion, whether the data is more scattered or less scattered, that is more dispersed or less dispersed, that is all about spreadness. Now for example, if I have some data such that like 4 or 6 observations, if I have those 6 observations, if I do if 60 observations, 6 observations means by seeing that one you can understand whether it is less dispersed or more dispersed. So 60 observations if you have, wait, so fine. Let's talk about the 6 observations only now, just have an idea. For example, if I took the 6 observations such that 1, 9, 15 and 20 and 25 and 31, if I have like this, and this is one model data model 1 you have now. So consider this one as data model 1 and data model 2, another data model 2 if you have. This data model 2, the same 6 observations you have. So those 6 observations were considered as like this, started with 1 and another one is 10 and 25, 62, 84, 100, 102. Like this if it is there, then the gaps in between these all individually you should count, and then if you check which one is there having the more spreading or less spreading, more scattered or less scattered, that you can observe. But if you have the higher number of observations, more number of observations if you have, then you couldn't calculate like this, because when if you are talking about the sales or something else about a business, the sales numbers won't be this much small, Nana. Those will be higher numbers and a lot of numbers you will get. To find the spreadness or scattered, how they are scattered, how they are dispersed, to find out these are required, the measure of dispersions. Now we will see what are the measure of dispersions we have. Here the measure of dispersions we can consider as range is one of the measure of dispersion. So as range is not that much efficient, we considered one of the sub concept of this, that is called interquartile range. Interquartile range. So after completion of the interquartile range, we had considered the next one, that is semi-interquartile range. Interquartile range. And then as these all are not that much efficient, we will go to the mean deviations. This is the known thing to you, that is mean deviations. Either the mean deviation could be above the mean or above the median or above the mode. So after completion of this, then another important measure of dispersion is standard deviation. This is the most and vividly used measure of dispersion in all over the business mathematics or wherever that data models you have. So this one is the best thing that we will use. So then this one is derived from the variance. So that you will learn. That is also a kind of measure of dispersion from the variance. So due to some inconvenience in the variance, that is to eliminate the square that we considered in the variance, we took this one square root. That is the advanced version of this that you can consider like that. And after completion of this, then you can consider the square deviation. So square deviation, these are the measure of deviations that you have. But in your syllabus, you have only the range and mean deviation, variance and standard deviation, and the coefficients you have, like coefficient of variance, coefficient of standard deviation, coefficients of mean deviation, that's it. So just for the knowledge point of view, learn what is range. In your lower standard that you know, the range is nothing but higher observation, highest observation, or the maximum observation which is maximum in the given observations. So maximum observation or observation having the maximum value. So consider x max minus x min. So you know that xi is considered as the observation rate. So when you consider xi is the observation, then x max is the observation which has maximum value, and x min, that is the observation which attains the minimum value. So this is called the range, but range is not that much efficient to discuss about the dispersion of the data, Nana. So this one we talk about how the data is dispersed in in qualitative manner, not in quantitative. Like when any production works are going on, so the number of goods that are made in the one day could be different for the another day. So that is the number of goods, the difference, that higher number is made on one day to the lower number made on another day, that comparison that you can take. So this is the range that is used to find the measure of dispersion when the qualitative comparisons of the data models when it is coming. So generally measure of dispersion is talk about how the data is dispersed, and to compare the measure of dispersions of the two data models, two measure of dispersions you want. So here two data models when you have, which is the qualitative one, and which month or on which day the production is got more production. To find out that kind of things you will use the range. So this one to make much more easier, much more efficient, interquartile range that we had discussed. Till now you saw right what is the meaning of quartile and upper quartile and lower quartile. So here the interquartile range is nothing but upper quartile minus lower quartile, Nana. This is the interquartile range it is. Now semi-interquartile range, it is much more efficient because here a lot of goods when you have, out of those all goods, the first, the least and the maximum, those both difference only you took. Meanwhile, how the data is among themselves, how the data is spread, that you don't know. So that's why made into some small groups. So at that time, if you made into some small groups, that means if you made into 4 equal groups, then in each group how the data is transmitted, how the data is spread. So to find out the interquartile range, it is done. So semi-interquartile range means the interquartile range by 2 is called semi-interquartile range. Now let's see, as these all are not there and not much important for the exam except this one. So this one also not that much important. The questions found from this is the basic thing that you already observed in your IPE or CBSE, that is mean deviation. So after the mean deviation, whatever the obstacles or whatever the limitations that you are facing or complexities that you are facing in the mean deviation, we make somewhat simplified measure of dispersion we made, that is called variance. So to rectify the errors that we are getting in this, then we introduced one more, that is called standard deviation. So under the coefficients that you take, this square deviation is nothing but the root mean square of the standard deviation only, Nana. So this is also not there in your syllabus, so you can eliminate. So this is also not required. So this one just learn and keep your concentration on mean deviation. Let it be about mean or about median or about mode. about mean or about median or about mode. So in generally, if they gave mean deviation, then we can consider that is a mean deviation about median. So that is the middle value, right? That's why. And standard deviation and variance, these are the most important things. So we'll see one by one what they are, what their formulas, how their behavior, how they are useful to compare two data models. So those we'll see. So let's start with mean deviation. So alright guys, what is mean deviation? As a name prescribed in this, mean deviation is nothing but mean of the deviations. Deviations means how far it is from the parameter that what we have. So if you have a data model, in that data model you have a lot of observations, bulk number of observations you will get. Out of those all observations, so we should take a parameter that could be either mean or median or mode. So from mean, if I took the mean, from the mean how far they are. So that is the difference between the mean and that particular observation. So those are called as median deviations. So here mean deviation about mean if I consider, so what is the meaning of this? First you need to find out the deviations about the mean and then take the mean of them. That is nothing but mean of any items, that is mean of the observations that you know, sum of the observations by number of observations, that's it, right? So here consider these deviations about the mean, those are nothing but mean deviations. So consider those mean deviations only as the observations, find the median to them, that's it. So if I have an observation xi and this is considered the observation that we have, several observations you have. So based on the value of phi, the observations you can get. So this one is observation, particular observation if you consider, and x bar if I consider as a mean of the data model, mean of the data model. So now the deviation is nothing but xi minus x bar nana. So xi minus x bar if you consider, then the mean of these you should find. So if n number of observations were there, n number of observations, n is considered as the number of observations. So number of observations when n you have, then how to find the mean? That is nothing but sum of observations by number of observations. Sum you can take with sigma. You can take with sigma. So sigma of this by n you can consider. So this is nothing but mean deviations about mean. Clear? For what? For discrete type, for individual type data. For individual type data it could be. Individual type data is nothing but the raw data. Raw data is nothing but the data that what you gathered from the first sources. Right? So just you collected and just you left them, those data. So now from here, if the mean deviations if you need to find for the discrete group data, it is ungrouped data. For the grouped data, actually grouped data will have two models, that is one is discrete grouped data and another one is continuous grouped data. Those both are frequency distributions only. Each observation based on the number of times it is repeated will allot one number to that is called frequency. Clear? So here for the grouped data, if I consider discrete grouped data, so for the discrete grouped data, for each observation, if they are repeated f number of times, then summation of, if for example, if 2 is there an observation, if 2 repeated 5 number of times in the data, so sum of those are how you can consider 2 plus 2 plus 2 plus 2 and so on. If it is 2 repeated 120 number of times or 2000 number of times, so instead of adding 2 plus 2 plus 2 we multiply, right? That's it we are taking here also. So 20 times if 2 repeated, then 20 into 2. So like that, if xi like that f number of times if you have, then f into xi will consider. So that is nothing but if how many number of observations are there based on their particular frequency, fi into xi minus x bar by n you can consider. This one is nothing but summation. If you consider to these only, then here summation of f5. This is nothing but number of observations. This is nothing but sum of the product of frequencies and the median distributions, median deviations. So this is mean deviations about mean for the discrete group data. Clear? Now for the continuous group data, what we will get? For the continuous also same, there won't be any change, because whatever the thing that we should do, that we found the either assumed mean or step deviation that we had used in calculating the mean of this. Clear? So this one is continuous group data mean also. I mean mean deviations about the mean, right? So if it is about the median, if you have, what you should do? The simple thing, instead of here mean, you will take median. That's it. Because we are taking the mean deviations about either mean or median or mode. So if you have median, the about median, if you need to find instead of this one, so in the place of mean you can consider the median. So this one will become the median, or else this one will become the median. That's it. Clear? So that is mean deviation about the median. You might observe already in your IB or in CBSE syllabus. So there we did 7 marks problems or the long answer questions by having some tables. So each table having few columns. Those columns are having the individual values of this, like xi minus x, and then in another column f into xi minus x. At last we added those all. Those you can consider, Nana. So once you compare with them, that's enough. Right now, let's see, when you have a measure of dispersion, by taking that measure of dispersion, you will get to know what amount of the dispersion had done in the data model. So, but you should know whether which data model is more dispersed or less dispersed. At that time, comparison should be done, right? To compare, we should require some coefficients. Those coefficients can be considered as here coefficients of the mean deviation about the mean, coefficient of the median deviation, or mean coefficient mean deviations, median coefficient mean deviations, or mode coefficient mean deviations. Those you can consider. So those are nothing but the coefficient of the mean deviations. You can consider what you can consider mean deviations about median, mean deviations about median or about mean. Based on the required thing, coefficient of mean deviations about mean if you want, mean deviations about mean if you want, you need to take mean deviations only. About median if you want, you need to take median deviations only. Whatever you will take in the numerator, that is based on the required thing only you will take. But denominator will be always mean, arithmetic mean of the data model. That's it. So based on that coefficient, you can able to find whether the data model, which data model is more dispersed or less dispersed. But here, to utilize this kind of measure of dispersion, we have some complexities, some errors you will get. Those errors are because of these values, these deviations are there, right? Those deviations can give, some of them are negative values, some of them are positive values. So to make the among themselves, those will get cancelled. So as those are getting cancelled, so then we can get the unknown errors, the different errors we may get. So to avoid those errors, we can take them in mod. That means just we are considering the absolute values of them, absolute values of mean, absolute values of mean deviations or median deviations that we consider to find the measure of dispersion. So to avoid the cancellation of the deviations among themselves, we are taking the mod. So by taking the mod, we may get some errors. To avoid those errors, we will introduce another concept by taking the square of the deviations, that is called variance. So now let's go to the variance. Before we are going to the variance, so consider here, if instead of mean, if you have median, then it would be mean deviations about the median. If instead of median also or mean also, if you have mode, then those are called mean deviations about the mode. Clear? So their data models and how to find the mean deviation of the data models and median deviations of the data models were there in our IP syllabus that you can see. In one video after completion of these concepts, in one video we can teach you how to find the mean deviations and median deviations and the standard deviations also. Clear? Now let's go to the next concept, that is called variance. Alright guys, so now let's see what is the meaning of variance. Variance is nothing but, as we already discussed, when we have the mean deviations about mean or about median or about mode, we took the absolute values of the deviations. Clear? So there, because of taking the absolute values, some extra which are need to get cancelled, those also you will get, which are doesn't require those instead of cancellation also if you want. So those to avoid, so instead of taking the mod, let's take the square of those deviations. That is, here mod xi minus x bar was there, right? So if I take the square of that, then if I find the square mean of the square deviations, so mean, arithmetic mean of the square deviations of the individual values from their mean, then what you are going to get from the mean, clearly one more time, from the mean only we are taking the variance. So some other observations, that is the deviations about the median, some deviations about the mode, that you doesn't require to learn here. So the arithmetic mean of this if you need to learn. So this is each median, one median rate it is, one deviation rate. So this deviation square, this is called square of deviation. So this kind of deviations you will get n number. So that is I is equals to 1 to n. So the number of observations are n if you have. To find the mean of that, you should get divided by the number of observations. This is called the variance. So the variance is generally denoted by sigma square or sigma x square. Sigma x is denoting the variance, and here if I took the square root of the variance, that is square root of summation I is equals to 1 to n xi minus x bar whole square divided by n, this is called standard deviation. This is called standard deviation, means whatever we took the squares, to eliminate the deviation squares, we will take again the square root. So to make some more precious, so some more accurate, we took the square root, that is called standard deviation. It is denoted by sigma x. Clear? Now, so how to find the either variance or the standard deviation for the other types of the data models? So if this is the data model for the raw data or the individual data or the ungrouped data, so these are the formulas for the ungrouped data. These are formulas for ungrouped data or raw data or individual data. So nothing simple of the topic. So if the mean of the squares of the deviations about the mean is called the variance. Square root of variance, if you observe this one, this can be written as square root of sigma x square also. That is nothing but sigma x, right? So that is nothing but standard deviation is nothing but the square of variance, or if you want to tell the mathematical definition by the words, so then you can tell square root of the square deviations, square root of the mean of square deviations about the mean is called the standard deviation. So these are the formulas for the ungrouped data. Now let's see the formulas for the variance and the standard deviation for discrete data, group discrete frequency distribution tables. Discrete frequency distribution data model. Discrete frequency distribution means this one is a kind of organized data. So then this some more well organized data is called continuous data model. So for this, how to find the discrete, variance and the standard deviation? Simple thing, if each observation is having this much deviation, if this kind of observations are n number, f number if you have, then what you should do? That is summation I is equals to 1 to n fi into xi minus x bar whole square whole divided by summation fi. This is the discrete frequency distribution. I mean variance for the discrete frequency distribution. And the standard deviation is nothing but for this also I get the square root of the variance whatever you got here, that one only. Clear? So now the same variance or the same standard deviation for the continuous frequency, what it will become, we'll see. So here one thing we should remember, for the previous one, the mean and median deviations that we had seen, at that time we were finding the only mean deviation. So you got the same formula for the discrete data model and continuous data model. But here, as along with them they are taking the squares. So by finding the squares and then simplifying, I mean multiplying and then simplifying, so that one will become so tedious. So it will make some more tired and complex calculations you will get. So because of that, we introduce some several methods Nana here. So first we learn what is for the continuous frequency distribution, what is the variance, standard deviation. Later, what are the other shortcut methods we have for to find that one, we'll see. Clear?